Assalamu alaikum everyone. Can you all guys hear me?
Hello. Hello and Assalamu alaikum to everyone. I'm Zainab and I would like to welcome you all on behalf of DICE Analytics to the round 5 of DICE Webinarly 2021. Enough talk, let's DevOps. It's a great pleasure for me to introduce our speaker today, Mr. Ali Kahoot. The expert trainer and speaker has been associated in this industry since more than 6 years and currently working as DevOps engineer at Tarabut Gateway. In today's session, you will be exploring all about DevOps, its tools and technologies, its best practices. You will learn what is continuous integration and continuous delivery, why is it the highest paid job, and why you should move to DevOps. It's a request to all the attendees to note your questions during the session and ask your queries in the Q&A session at the end. I hope we all enjoy this session. Thank you so much. Over to Mr. Ali.
Thank you so much, Zainab. Uh, okay, so we have a participant from Philippines as well. That's good to hear. Okay, so let's before starting, I will be basically asking some of you to introduce yourselves. So, Amir Jan, can you introduce yourself? What do you do and where do you work? Okay, so I am made the host. I will ask you to unmute yourself. Basically, I can't see the button. So okay, so now I'll allow to talk. Amir Jan, I have asked you to unmute yourself. Can you introduce yourself a bit? Okay, I think so. Amir Jan is not willing to talk, so let's move to Ali Arslan. Can you please introduce yourself? What do you do?
Yeah, can you hear me?
Yeah, I can hear you fine.
Oh, yeah. I work as a software engineer, mainly in Python and C++ in Berlin, and mostly related to the autonomous industry. I'm just looking for some new skills, and that's why I'm here to learn more about DevOps.
Hello. Hello. Yes, Hania. Can you hear me?
Yes. Hello.
Yes, Hania.
Hi. Hello, anyone? You can hear me now?
Yes, Ali, we can hear you now.
Okay, I think so. The mic was muted by my system. Okay, sorry for that. Okay, so I will start again. Welcome everyone to the Roadmap to DevOps session. My name is Ali Kahoot, and about me, I am the DevOps engineer at Rabut Gateway. I have recently joined around a month or two ago. I am a DevOps trainer at Dice Analytics as well. I am a freelance DevOps consultant. I worked as a team lead DevOps engineer at Stackator and a software engineer at Bentley Systems. So I am certified in the Red Hat Delivery Specialist container platform, and some of my technical expertise are related to Git containers, setting up CI/CD pipelines, using GitHub Actions, Jenkins, and such tools. And I have also worked on Kubernetes and OpenShift. So, and these are my social media links. So if you want to connect, you can do that over there. So, what should one do when he wants to move to the DevOps field, or why should one move to a DevOps field? So, that question comes to the mind, that what is DevOps? Basically, what is DevOps? So, why do I need to move to DevOps? So, in the early 2010, basically 2005, 2006, and even till 2015, I would say there was an increase in the market for software developers. Every company needed a software developer because they needed to develop the software at that time. At that time, companies didn't have software, and they were moving from a manual logbook to an automated systems. So they needed software, needed websites, they needed applications. But nowadays, every company, every local store, every basically each and every store has a software. It has a website, it has an application. So that problem is now solved. So the software development that has been done, now what is the issue? The issue is they want to frequently deploy new features, and they want to maintain the existing infrastructure. So how can one do that, basically without disturbing the current ecosystem and without disturbing the current infrastructure? So how can basically one do that? So and every software has to run on servers. So who would be managing the servers? Who would be managing the development part? Who would be managing the operations part? So all of that resulted in shifting blames. The developers started blaming the operations guy for delays, and the operations guy started blaming the developers for delays. What happened was that a developer developed his application. He basically tested it on his own machine. It worked fine, but when it went to the dev environment, when it went to the QA environment, and when it went to the production environment, there were some issues over there, which the basically operations guy had to solve, and they didn't have any technical expertise, so they couldn't solve those issues, and they blamed the developers that there is an issue in your code, and the developer blamed that it works on my machine, so it is related to you. So then it can always take days to release a new version of software. If you have a new feature and then you wanted to deploy it, it will obviously take weeks to deploy that new feature. And then you take the customer feedback. There is a saying in the software field that the customer never knows what he wants. It is a very particular saying that the customer never knows what he wants. So when you take the customer feedback, the customer will say, I did not want this, I wanted something else. So you would have to do all the process again. You would have to again redevelop all the features, and then redeploy all of those features again. So that was a particular issue that was causing a lot of basically delay when you wanted to deploy a new feature, or when you basically wanted to excel in it. So time is the key nowadays. For example, if I give you an example of Snapchat introduced stories, but in the meanwhile, what Facebook did was Facebook also introduced stories, WhatsApp also introduced stories, and all of those things started happening. But if Snapchat was not evolving, or if Snapchat had delays in it, their basically software development, the new features, Facebook or WhatsApp would have taken the market at that time. So time is the key over here. You need to deploy new features frequently, and not just you have to develop. In 2015, till 2015, there were no markets, or there were no companies who had enough software. So now They all of them have software, all of them have development teams, but now the key is time. You have to deploy it frequently. And then the issue occurred that worked fine in DevOps problem now. So developers didn't care much. Developers said that this all depends on the operations now. It was working fine in my on my machine, so now it's not my concern. So the responsibility was not being basically taken by all of them. So just a question over here, just to keep it a bit interactive. Why do you think that this occurred? Why do you think that this issue occurs, that the software works fine on the developer's machine, but when it goes to any other environment, but it does not work over there? So any one of you, I will uh, try to unmute. Yeah, Kirtana, you want to add
Yeah,
anything? Yeah.
yeah, definitely. So the thing is like maybe there are the version issues or compatibility issues, the environment in which the developer is trying to perform the new code changes, trying to implement the changes, whereas what the environment or the setup that the QA or the UAT team has differs maybe the
Yeah,
environment related other things.
yeah, sure. That's one of the issue. I will allow Tanzil to talk if he wants to. Tanzil, can you share what do you think that why this issue occurs? One of the reasons Kirtana has shared. Any other reason that you want to share yourself? Tanzilur Rahman.
Sorry. Hello.
Yeah,
Hello. This is Tanzil. Yes, Ali, I agree with you. There is a lot of changings when developer have defined the codes and they give to the operation team to deploy at the on the servers. So there is a lot of changing happen because sometime there is a mismatch with the libraries. So and operation teams are blaming to the uh, development team today this code is not working properly running on that particular servers.
sure.
So
Okay,
and after that these things are many times happen we have seen in industries. And now the this DevOps means that DevOps give us this opportunity that we can if we can learn these things and developer and operation team will work togetherly and they can easily deploy whatever they wanted for the as per industry standards.
sure. Sure, sure. Thank you so much, Tanzil. Okay, so now coming back to basically why this issue occurs. So one of the reason is basically the compatibility issue. The developers, maybe they are using a Ubuntu machine, and the dev server or the production server, they are based on rel, majorly the linux system that is used on the production servers, that is rel, the red hat enterprise linux or any other version of the linux kernel basically. So what happens is in basically Ubuntu, you install, for example, Java through sudo apt get install Java. But in and you install the version, for example, Java 8.9. Let's say I'm just assuming 8.9. But when you go or the operations guy installs Java on the production server, he installs 8.6, for example. So there is a version compatibility issue over there. Operations guy does not know what kind of the exact environment do you need. Then the other issue can arise, basically you are running just your application. I am a developer of one team, so I am running my application alone, so I can easily run that. But when that goes to the production server, there multiple applications have to run. For example, my team's applications are also running, and the team B's application is also running over there. So now the port compatibility issue can also occur. For example, my application also runs on the port 8080, and other team's application also runs on the port 8080. So that can cause another issue. So there are multiple reasons that this issue can occur, and to debug those issues, or basically to treat it as a one fits all solution, that cannot be possible over here, because that totally depends on the scenario, that what kind of a scenario it is and why this issue occurred over here. So it all resulted it into the product delivery cycles were basically slower, and the less ambitious projects were being taken by the companies, and they were not able to deliver the exact features or the quality features in time. So the organization in the end was basically taking a financial hit, the monetary hit. The actual thing that matters to the company are the finances. So if they are not getting quality projects, or if they are not delivering a quality product in time, so that does not will not create revenue for the company. Now coming to the software delivery lifecycle, how things changed during the time. So previously it was waterfall, where you had a software requirement engineer who went and gathered all the requirements. For example, it took around 1 month to then design the whole architecture, and then it took 2 months to code that. Then again, it took 1 month to test it, and then 1 month to deploy it. For example, it all took 4 months to from the design phase to the deployment phase. And now when you show it to the customer says, I do not want this kind of stuff. This is not what I asked for. Because as I told earlier, there is a quite common saying that the customer doesn't know what he wants. So at the end of it, the customer will say, I did not want this. You have totally deployed anything else what I wanted to on my software. So you have to do this all of this process again. Then came the agile software development lifecycle, which said that first you design the application, how you will basically the architecture of the application. Then you have small sprints. For example, you can have a 3 week sprint where you plan that how much of the features you will develop and deploy, or basically complete in this sprint. So for example, I have a 3 week sprint. So I first have a meeting where I gather all the requirements, and I say, for example, the feature 1, 2, and 3 will be completed in the first sprint. The feature 4, 5, 6 will be completed in the second sprint. So and at the end of the basically the release cycle, the all of those gets deployed. Then again, the issue was you had to wait for the sprint. Nowadays, as I said, that the change is inevitable. Change is happening each and every minute. So if you are waiting for 3 weeks to add a new feature, there is an urgent feature to add. But according to Agile, the sprint is blocked. You cannot add new features concurrently. So you basically in a sprint, whatever features that you have accepted, you will only complete that. But that's not the case over here. Then came the DevOps methodology, where and also you have to wait for the release cycle to deploy all of that into the production server. Then came the DevOps. DevOps says that you code it, test it, and deploy it. So, for example, the feature 1, as soon as it gets completed and tested, you deploy it onto the production server. It does not matter that if feature 2 is completed yet or if it's not. If feature 1 is complete, you just deploy it as it is. If you are confident that it is completed, you have tested it, you deploy it as soon as it's working or it's in a working state. So this is sort of a diagrammatical difference between both of them. Over here you plan, design, and this was a sprint. You completed the sprint and then you launched it. But over here what you are doing is have the whole cycle continuously going on. You plan it, you plan basically the sprint, or you plan the feature part, you code it, you build it, test it, release and deploy it onto the production server. Then you also monitor it, that how it's working and how, whether it's up or not, whether the application goes down by somehow or not. So that's the difference between agile versus DevOps. So what DevOps provided was, it provided a continuous feedback loop and a quick release or fail process. So what it meant was that if the code is correct, for example, my feature is complete and it is tested well, the code is correct by all sorts, you deploy it, you release it, and take feedback from the stakeholder. The stakeholder can be your customer, that can be your client, or the stakeholder can be your project manager, your product owner, your if you are a product company. So the stakeholder can be the product owner and you can take feedback from him. And if there is an error, for example, you have created a wrong binary, or for example, you have a code in your error in your code, so fail the fast and give the feedback to the developer that this line is failing and this line of code is failing. So basically what it meant was that continuous feedback loop. So if you Google DevOps, so you will always see this sort of an architecture over there. So all of these parts, what we when we say that what are the responsibilities of a DevOps engineer, so each and everything mentioned in this cycle is the part of a DevOps engineer's job responsibility. He needs to plan code as well. So a bit of coding is required for DevOps. At least a bit shell scripting knowledge is required. You build the code, you test it, and you are not doing it manually, mind you, that you are not doing all of this manually one by one. This is all should be automated. So these are some formal definitions of DevOps. I will not be going into the details of it. You can Google them by yourself, and basically you can see what DevOps is. And just I will go through one of them. DevOps ultimately means building digital pipelines that take code from a developer's laptop all the way to revenue generating prod awesomeness. So according to me, if someone asks me what is DevOps, and I have to define DevOps for a layman who doesn't understand, so what I say is that you take the code from the correct code. Or okay, one of the main point is the correct code. If there is an error in the code, you have to tell the developer. You take the correct code from a developer's laptop and you deploy it onto the production server. All of the parts in between should be managed by a DevOps engineer. All of that part is the DevOps process or cycle, and that should be in a quick way and should be in an automated way. There should nothing be manual as such. So all of this is the process is known as the DevOps cycle. Now coming to why should one move to DevOps, there is a okay that it's a buzzword nowadays. DevOps is quite a buzzword, but why should you, or why did I even move to DevOps, and why should you move to DevOps? At the end of the day, it's all about money. So I will be sharing about that as well and the trends for it. So this was the trend in 2019 of DevOps, that how exciting it got in 2019. And in 2020, after COVID, things went exponential because everyone was relying on quality software. Everyone was relying on good quality servers, good quality monitoring for basically helping their softwares to run quickly and basically scale quickly as possible. So DevOps really got excited in after the COVID scene. Now coming to the salary, this was a survey done by Data Carrier in 2018. The average salaries in Europe. So if you can see, these are in €1,000. Italy, Belgium, France, Germany, Switzerland, Austria. So these are the average salary, annual salary in €1,000 in Europe. This was a survey done by Stack Overflow in 2018. Here you can see that a DevOps specialist is even higher paid than a data scientist. In Pakistan, most of us know what data science is, but the irony is that we don't know DevOps. In our universities, in our institutes, DevOps is not being taught as much because they themselves don't know. DevOps is a path where if you don't have a hands on knowledge, you cannot learn by just reading about things. You have to have hands on knowledge. So, this was a Stack Overflow survey done on 2019. This is the link. You can go and verify it yourself. And then in 2019, Stack Overflow again did the same survey. So now in United States, DevOps is the highest paid job. Data scientist is at second number. United Kingdom, DevOps is the highest paid job. India, DevOps is the highest paid job. Germany, DevOps is the highest paid job. So why is DevOps the highest paid job? Because there is a scarcity in the market. There are not enough good resources in the market. So the ones that those are skilled enough, they can easily basically negotiate on their own terms because there isn't enough supply. It's all about supply and demand. The demand is high but the supply is less because our institutes are not teaching this basically DevOps because they might be that they themselves don't know about DevOps that much. And that's why we are conducting such seminars, that people should be aware of such things and start moving towards this career path as well. This is a Glassdoor survey that the average salary for a DevOps engineer is 1,015 K dollars. The other salaries related to DevOps are site reliability engineer, release engineer. So all of these come under the same umbrella. And this was an article, even though it was in 2016, I wasn't able to find the latest version for it, but this was the hardest job to fill for a recruiter. For a technical recruiter, DevOps is the hardest job to fill. And the recent acquisitions, Microsoft acquired GitHub, I think so, in 2018 or 2019. It acquired GitHub. That was a major acquisition, and it basically changed the way how CI/CD pipelines work. They started adding GitHub Actions and all of those. We will have a demo after the seminar, hopefully, of GitHub Actions. IBM acquired Red Hat. Red Hat is a major player in Kubernetes, OpenShift, and DevOps related stuff. So IBM acquired Red Hat. Mirantis acquired Docker. Docker was the company that basically started the way of shipping containers. So Mirantis acquired that. So how can you become a DevOps hacker man, and how can you basically move to a DevOps engineer path? The question is again comes to this. Okay, okay, so there are some best practices for a DevOps that you can basically work on and improve the skills and improve the related technologies for it and work on the related technologies, and then basically you can move towards a DevOps path. These are some of the best practices. I will be going through one by one. Uh, some people are raising hands, so let's ask them. Okay, so Zan Gilani, you have a question?
Yes, so I've asked a question. If there are so many tools like Jenkins, Docker, Ansible, and so much more. So can you please tell which tool should a beginner start with and what should be the path that we should follow to master
Okay.
these technologies?
Okay, basically that will come after that, so I'm not covering that over here. So that was the sense that we basically asked for the questions at the end, because hopefully some of the questions will automatically be answered when you attend the seminar. But
Okay,
if there are any other questions at the end, I will be more than happy to help you at that point in the
okay,
end.
thank you.
Ali Arsalan.
Yes, as you said, we should deploy more frequently to the production, right?
Mhm,
Cycles. But let's say I write a new feature and there were no synthetical errors, just some logical ones. So
mhm.
shouldn't it be better to first push it to some staging area where the QA can test it and then we push it to the production or something?
Yeah, that will also be covered later on. By
Okay.
meaning that to deploy on the production server, that means to have all the stages passed. So obviously there is a stage behind production. Obviously there is always a dev environment, a stage. If there is the product depends on the product. If the product is quite high quality, so there is a dev stage, QA, production. But if it's a low product, low project, low team, there can be two, at least two environments, dev and production. So first you test on the development, and then you deploy it on the production. That will be covered in the continuous deployment part. So
Okay. Okay.
okay, so these are some of the best practices, I think so. Okay, first is the continuous integration. What does this mean, and how basically this works in parallel with the DevOps thing? Is it means that you merge the code changes from different developers into a central repository. For example, if most of you should have, I would say should have worked on Git or GitHub in your university time, but sometimes, or basically even in my path in my university, I wasn't taught Git that much. I was just given a brief introduction of Git, but I believe that should be made compulsory. So if or you have any idea of Git, so what happens is you can create different branches or for your features. For example, if you have a master branch, you create a new branch out of the master branch and you work on that feature. And as soon as you believe that this feature is completed, for example, that will be told by the unit tests. I will show you the diagram later on. You will better understand that. You merge it onto the master branch. You merge the feature branch onto the master branch. So automated builds and tests are run, you do not have to do that manually. Or the whenever you push to a branch, push to your code repository, an automated build will start running. The key goal is to fail fast and find and address bugs quicker, so that if a developer has any bug on his machine, on his code, if the unit tests are failing, so unit tests come into practice over here. Unit test will basically tell you the issues in your code, the basically syntactical one, or some sort of a basic logic one as well. So that can be covered through unit tests. So this is an organization, Silver Stripe. So how they do code in continuous integration is they are using GitHub. They create a new branch. They push onto that branch. Unit tests are run. The code analysis is done through Selenium. They check whether the code is up to the mark or not. It has the quality or not. And then the test coverage is shown, that how much code is covered, and all if all the tests pass, then you can release it. Basically you can release it to the next stage. So this is the continuous integration part, where the unit tests are run, code analysis is done, and the test coverage part is done, and then you release that code or release that branch. Basically what that means is you merge the feature branch onto your dev branch, for example, or onto your master branch. The next thing is continuous delivery. So there are, when you we say CI/CD, so by CD there are two terms: continuous delivery and continuous deployment. So what continuous delivery means is, and I will show you this diagram, you can better understand it. So continuous integration is done, the branch is merged onto the dev branch, let's say, or develop branch or master branch. You deploy it onto a staging environment or any sandbox environment, whatever environment name you give in your team. You deploy onto that. That is all automated. So till the staging part, it's all automated stuff. You can deploy it onto the staging part in an automated way. Then, for example, you have a manual QA testing to be done after that. So a manual QA tester will test all of those stuff, and then he will pass it, and then you can deploy onto the production in a manual step. So this is the delivery part. You are delivering the code till the production, but you are not deploying it. You are just delivering till the production. The other term, continuous deployment, means that continuous integration is done, continuous delivery is done. For example, staging is also automated. But once the staging is automated, staging has been up, for example, the staging environment is up, now you run automated UI tests as well. So for example, in your team, you have written all the tests are automated, the UI test, the end-to-end test, or the integration tests run. They verify your application is correct 100%, and then you deploy it onto the production as well in an automated way. So that is continuous deployment. A brief basically difference between the end-to-end tests and the unit tests is, so for example, in unit tests, you just check if your code is changing that microservice or not. So for example, if I say I am creating a table, so and I have to create the foots of that table. So in the unit tests, I will just be seeing that if that foot of the table joins the table or not, or it attaches to the table or not. But in integration test, I will be setting up the complete table and then putting some load on it as well, and checking whether the table works perfectly or not in the whole environment. So that is the end-to-end tests that are run on the staging environment, and if they pass, then you deploy it onto the production server in an automated way as well. So very few companies have achieved the continuous deployment level. For example, Amazon does it, but still that is a long way to go, because for that you need a strong suite of your end-to-end tests. You should have enough confidence on them to deploy onto the production on an automated way as well. So now coming to what tools can you learn if you want to basically grasp onto the CI/CD processes. So Git, first of all, Git, you need to understand Git, how Git works. Then GitHub, GitLab, Bitbucket, either of these you can have a hands-on practice on them. All of them are sort of free. You can create private repos on them. Jenkins is a CI/CD tool. GitHub Actions, GitLab CI, Tecton CI, Circle CI. So these are all CI/CD tools. You can write scripts and all of those things over here. And similarly, IBM DevOps, Azure DevOps, Flux, and these are the CD tools. Flux and Argo CD are the CD tools to help in continuous deployment. So again, the tools for the DevOps realm is quite high. The number of tools, they are quite high. For example, there are different clouds. We will be covering the clouds as well. So there are majorly, I would say, 6 to 7 clouds even: AWS, Google, Azure, IBM, Oracle. So that does not matter. What matters is that you have expertise in any one of them. Even if you see any job description for a DevOps engineer, it will always be mentioning Jenkins or GitHub Actions or GitLab CI. No one is expecting you to be a master of all of these, but you should have an experience in one of them. So I will always suggest that you start learning one of this tool and you create an expertise on it. And if, for example, you have a job that is hiring the respective people, you tell them openly that I have expertise in one of these tools, but I can learn the other tools, because the concept remains the same at the back end. The concept is this: as I mentioned, delivery, you integrate the branches, you write pipeline to test your code, you deploy it onto the staging, you run the automated tests if there are any, and then you deploy it onto the production environment. All of this is done through scripting or writing pipelines or all of those things. The next principle for DevOps is microservices. So if you are a software engineer or a programmer, you must have basically learned OOP programming in your computer science background or in your bachelor's degree, the object oriented programming. Previously, what happened was there was one page and you used to write all the code in that. But what OOP did was, OOP said to have smaller functions that can be reused. So what microservices tells us is, you can have a smaller services rather than having one complete uh, large application. You can have smaller applications based on your business units, based on your own demarcation. You can have smaller services for them that can be reusable, that can be in any language, or that can be independent of the other one. So each service runs in its own process and communicates with other services through a well-defined interface. Well-defined interface means an API call. They will be doing API calls with each other to fetch data from the other microservice. And separate services means that each of them can have independent CI/CD pipeline, independent ownership, independent responsibility, and even independent language. So, for example, one microservice is written in Java, the other is written in C++, the third is written in Python. So that can be easily be achieved. For example, what happens is that uh, nowadays there are some legacy companies that have legacy code, for example in Visual Basic and C++. So they are unable to hire, not C++, C++ is not that much of a legacy code, but a Visual Basic or such basically code languages. So they are unable to hire people, because the fresh graduates nowadays, they work on Python, they want to work on the newer technologies, they don't want to work on Visual Basic because that's an obsolete language. So in this case, if you have multiple microservices, you can assign the guy who wants to work in Python to the Python team, the team that has the microservice in Python. So all of those would be independent. And for example, this is a monolithic application, this is an e-commerce application where all of the logic is written inside one code, and you have a sale going on. For example, you have a sale such as the 11/11 deal that Draz gives, for example. So the people like me who just do window shopping on such sales, they are quite high. So the 90% people, they will just be doing window shopping. So but what that happens is, the load comes on the inventory or the products, the logic, the code logic, not the, because this is a monolithic service. So the load comes on the inventory logic and the products logic if you have a monolithic service. For example, as I said, on 11/11 deal, or on, let's say, Black Friday deal, the basically the visitors of these e-commerce application goes exponentially, they drive exponentially. So if you have a monolithic service, you will have to scale this complete service, this complete monolithic service, even though the load was only on these two code logics. So what you can do is you can divide this monolithic service into a microservice based architecture. So accounts can have its own service and its own data. It can be in Python. Orders can be in any other language. It will also have its own database. Products again, promotions, inventory, and all of those will be showing onto your browser the same way as it was being shown previously. You will fetch the data through API calls and consolidate it into the front end. So even if the account service goes down, for example, the account service goes down, I, being a window shopping guy who will just log in or who will just go to that website to see the products, I will not do the complete shopping. I will not even know whether your application is down or not, because I will not log in. And if I don't log in, the account service will not be called. The products, the orders, and the inventory, oh, sorry, not orders as well, products and inventory will only be called. So I will not even know whether your application is down or not. So in that case, in that way, you can actually basically have independence between those microservices. These are some examples for basically some companies that are actually working on microservices. So Netflix has around 500 plus microservices. Twitter again also has 500 plus microservices, and the lines that you are seeing over here, the blue lines, those are the actual the API calling that is being done between the microservices. So you can see the overall architecture is a bit complex, but if I am a part of a team that has to work on this microservice only, so the complex logic, if it was all written in one service in one code, how complex that would be, rather than only having to understand this one microservice from here. Again, Amazon, it has a lot of microservices. Don't know the exact number, but it will be in thousands, I believe. So when you come to microservices and when you move to microservices, so containers and Kubernetes are the de facto basically way of deploying microservices. There is no better way of deploying microservices rather than containers and then running that on Kubernetes. There are many applications, many use cases that have been covered. I will just share one. For example, a year ago, I would say a year ago or 2 years ago, a game became quite popular, Pokemon Go. All of my friends even started using that application. They started playing that game, and the users for that application grew exponentially. They were reaching basically millions of users new day, millions of active users new day. So behind the scenes, they were using Kubernetes, and they easily scaled up their infrastructure as the load increased. And same will be done over here in cloud computing as well. Same is the use case of cloud computing as well. You can, I will cover it again, just showing you that use case or sharing that the same use case will be shared over here. So the scale, the load increased, so they had to increase the scale up their application as well. So they had to increase the infrastructure as well. So what they did was they added nodes or physical nodes or for their applications using cloud resources. So they easily scaled that up, and after 2 to 3 months, when the buzz came down, so the active users started basically decreasing. So they scaled all of those things down again. So Kubernetes and containers are the de facto form or the industry standard for deploying microservices. They can't be covered in this seminar, but in our course we focus majorly on containers. There are 2 weeks that are totally focused on containers, Docker images, writing a Docker file, Docker Compose, Docker Swarm, and then 2 weeks overall on Kubernetes. So the microservices related tools that you can learn are basically, first is the API gateway. Okay, I missed that part, I think so, from here. So this is the API gateway. When you have a microservices based architecture, you need to have an API gateway which will be communicating with all the microservices. So you don't expose all of the microservices, you expose the API gateway only. The gateway is the only way how the client will interact with the microservices. So you can write an API gateway, or there are already some written as well. You can write your own. You can use Azure AWS API gateway, 3Scale, Nginx, Tick. All of those are some sort of an API gateways. Then the messaging, for example, an order is created. So this application, this order service will create an message onto the queue, and this inventory will read that message from the queue because it has to decrease the inventory. So orders will write a message, inventory will read the message from there. So you need to have some messaging queues for it, Kubernetes for running the containers, Docker containers for running the code inside the microservices, service mesh, and comes the serverless architecture. Then comes the cloud computing, the one of the major basically fields in DevOps, which is a field in itself. I would say it is a complete field in itself. So there are a lot of certifications that you can do in cloud based, or basically anything for that matter. So what does cloud computing mean is that you can have on demand computing resources. You can have any public cloud, Google Cloud, Amazon, Azure, or any other such cloud, and where you can basically borrow the resources, or you can buy the resources for the time period, and you will have to pay in hours. For example, if I buy a VM from Amazon Web Services, the Amazon AWS cloud, I will buy a VM, for example, 8 GB RAM, two CPUs, and 100 GB of hard drive. So if I need to use it for 3 hours, I will only be paying it for 3 hours. And if I then want to give it back or terminate that instance, I will not be charged again. So the difference between is, previously what happened was I had to buy a complete server. If I want to run an application, I have to buy a complete server for myself, even though I do not need it for more than 3 hours only. So that was the issue. Over here you have on demand computing resources. Whenever you have a demand, you create a resource. So as I mentioned in the Pokemon Go scenario, they had a demand, they increased the nodes, or they increased the VMs on their cloud. When the demand came low, demand decreased, they scaled down the nodes as well. So you don't have to buy the resources permanently, you can just buy it for temporarily and pay for what you use only. The other thing is, there are elastic sources, you can scale up or down quickly. And self service, you can go and basically schedule, or basically ask for the resources yourself as well. You don't need a guy for that. You can just go on Amazon Web Services console and create an VM yourself. So these are some major clouds that are AWS, Azure, Google Cloud, Oracle, IBM Cloud, DigitalOcean, or you can build your own on OpenStack as well. Then comes the infrastructure as code. That is the fifth sort of a major principle in the major field in the DevOps realm. For example, you need infrastructure to deploy applications. You are a DevOps engineer, and you are given the requirement of deploying a Java application, a Redis database, MongoDB, and all of those things. So if you go to Amazon AWS and you create a VM, so there are almost 10 to 15 options that you need to select. So for example, you go and create a VM over there, then you have to fill the 15 options from there, and then you click create. And now you have to create hundreds of VMs. So will you be doing that all manually, filling the 15 forms for the 100 VMs manually over there? And then you have to install Java on it, you have to install Docker in it, you have to install Redis database in it. So will you be doing that all manually? That's not possible. So you have an application that needs Git, Jenkins, Tomcat database, and Nagios, and you have different environments, dev, QA, prod, and you need to run all of those applications across multiple environments. And if one of that environment goes down, for example, the dev goes down, QA and prod are still working, the dev goes down, you have to recreate the environment. Then again, will you be doing that each of that manually? So that's not possible. So what happens is you write the infrastructure as code. There are different tools for it, but whatever infrastructure you want, for example, you need a VM for 2 GB, 2 CPUs, 8 GB RAM, 100 GB hard disk. So you mention that in a code form, and you tell it that I need 100 resources of this specifications. You tell that the form that you were filling manually previously, now you tell that in the form of a code, and you just run that code, so it will create that instances for you. And when you want to delete it, you run the script to delete those resources that are in the form of code. So that can easily happen. The audit can easily happen: who created a resource, who deleted a resource, when was the resource created. If I go and manually delete resources, uh, you might not even know what change I did. For example, if I create a VM, I install Java in it, but on the other VM, I forget to install Java on that, because I am a human, and manual intervention can lead to errors. So if I forget to install Java on the second VM, that can cause errors. But if a script is running, script will run the same as it was running on the first instance. So that's the benefit of infrastructure as code. Can be on-prem or cloud infrastructure, and servers can quickly be created or recreated using standardized patterns. Easier to govern changes. Again, the audit part is quite important when you are issuing or basically asking for resources. So these are some basic use cases of infrastructure as code. There are multiple tools to do that: Terraform, Ansible. So there is a difference between Terraform and Ansible. I just will tell you that briefly. What Terraform does is it creates resources. For example, you need a VM, it will create resources for you. What Ansible does is, through Ansible, what you can do is you can configure your instances. For example, I have an instance where I want to install Java, Docker, Git, Jenkins in all of them. So you can use that through Ansible. But to create that instance, you can use Terraform. So these are the two major players in the infrastructure code. Puppet and Chef are also used, but personally, I have not much used them. But these are two major players that can do each and anything related to infrastructure as code. So main purpose again is to have a state and deployment manifest in any central place. So then you can add that code in your version control as well. So you can have Git, uh, for that matter. You can add all the code in the Git or the version control system, so anyone can access it. So if you leave the company, other persons can also understand what infrastructure you created by reading that code part. And then it leads to GitOps. So if any of you has an experience of Kubernetes and wants to go towards that path, you can Google GitOps as well, and I believe you will be amazed at how things are going in the next way. Okay, then comes the monitoring, logging, and tracing part. So uh, what logging means is, or what monitoring basically means is, the application is logs all of the happenings occurring in an application. The source code is logging that. But as a DevOps engineer, what you do is you collect all those logs from all those different applications into a central place. So you have three applications running, one, two, three. So you collect all the logs from those three into a central place, and then you query that central place. So a developer, you can share that logs with the developers as well, so the developers can easily see what errors are occurring, rather than telling the developer to go and look into the logs of application one, the logs of application two. So what you do is you consolidate, or you basically consolidate all those logs at a central place. And then you give the link, or you query the central place, and tell the developer that you can also query the central place if you want to search for a specific log. Logging is quite important. There is another photo as well in the next slide. So then comes the monitoring part. There are two types of monitoring. One is the cluster monitoring or the infrastructure monitoring, whether my infrastructure is basically enough or not. For example, what can happen is your infrastructure is being choked up. You have 8 GB of RAM and 7 GB of RAM is being used already. So that comes under infrastructure monitoring. You can have alerts for that. You can have alerts for it, alerts or perform real time analysis of data. So as a DevOps engineer, you would not be seeing the graphs whole day. That's not your part. You should not see the graphs whole day and see, oh yeah, this node's capacity is being choked up, this node's capacity is being used now. Rather than you will have alerts on that. So for example, if the memory is consumed 80% of one node, an alert should be generated and sent to you via email or Slack or whatever mode of communication you choose. An alert should be generated that 80% of memory has been used. So then you can go and check if you need to add another node or not. So that is alerting part of it, and monitoring and alerting and even logging, these are all very critical parts of your application, very very critical part. So teams can they monitor also, and then comes the application monitoring. So okay, so for the first was the infrastructure monitoring, the second is the application monitoring. So application monitoring means whether your application is working fine or not. The application is responding to the requests of the customer or not. For example, if one of your microservice goes down, so the application monitoring will tell you that this microservice has gone down, or this microservice has have an issue. For example, it's sending 500 responses. So 500 responses always means 501 502, that there is an issue in the server. So that can be managed through again alerting, that you can have an alert. For example, 200 500 50x responses have been sent, so you can have an alert on that. So this is the centralized monitoring and logging tool. These are all your microservices. For example, you have a central monitoring tool that is monitoring all the microservices running inside your cluster or inside whatever architecture you choose. And then there is central logging that can that will be basically consolidating all the logs from the different containers into the central place, and then you can query that. Then listen, this is one of the most useful thing for a DevOps engineer, because again what will happen is that when you deploy an application and an error occurs, for example, an error is reported by the customer, the developers will always say that it's not my fault. The developers will be quite keen to say that it's not my fault, it's the fault of the infrastructure, it's the fault of anything else. So if you have a central place where all the logs are located, you can use that, you can basically use that to know what issue actually occurred. That's not just to blame the developers, but that is an actual way of knowing what actually happened at that point of time. Because mostly what happens is, this is a human psyche, that we tend to reject it, that this is not because of me, I was not responsible for this thing. But when you have a central logging in place, central monitoring in place, then you can easily know what is happening and what's not happening. So and then comes the tracing part. The tracing is also quite helpful in a microservices based architecture. So for example, you create you basically send an API call, or you send an API call through the front end, and it takes 5 seconds. Previously it was taking 1 second only, but now it's taking 5 seconds. So how can you debug that? So what tracing does is, tracing, it will create traces of whether wherever the application went. So the total time it took was around 732 milliseconds, the whole API call. But how was it divided? It took 300 milliseconds for the first part, 200 milliseconds in the second part, and around 100 milliseconds for the other part. So that now accounts to the 700 millisecond time that is being taken for the API call. So the tracing again can help you a lot when there are delays in your application. So you can easily assess them by seeing the traces, that which uh, thing or which service is becoming the bottleneck for it. So the tools for it, again, Prometheus, Grafana, these are the, again, the de facto tools for monitoring in Kubernetes. The ELK, EFK stack, the Alert Manager, Datadog, Jaeger, Zipkin, these are the tracing tools. Nagios, PagerDuty is used for alerts and basically managing those alerts, who will be managing them. So these are the major tools for them. So think so. There are some questions I will be doing. That will be before for monolithic. Okay, there is a question over here. DB will be separate or can be one shared for microservice. What is preferable? Okay, I will let any one of you answer it. Okay, so the question is, should we have one database for all our microservices, or we should have separate databases for all of the microservices? Who would like to answer it? Kirtana, I saw.
Yeah,
Yeah,
can I?
yeah, yeah, sure.
Based on your previous diagram, maybe like each of the microservices hold an individual database so that the response time or the number of the hits that each of the services receives and the blocks that will it create will get comparatively reduced. So I think for each of the microservices, the independent database it can hold will be preferable.
Sure, that's one reason. Any other reason? Okay, Vajih, can you answer?
Assalamu alaikum. No, not exactly. I'm sorry. I'm absolutely blank and new to these things. I'm learning this, so I have no idea.
Okay, sure, no problem, no problem. We are all learning over here. So, any other person? Uh, Ali Asif, Ali Asif Khan, can you? Okay, I think so. Ali Asif is not replying. Rick Pedinas. Rick, I think so. Can you answer it, or should I move forward? Two participants. Who's the other person? Ali Arsalan, you raised the hand, so yeah.
Yeah, maybe we could divide the database like subject-wise, like accounting can have one database and maybe the like inventory can have a separate one that don't depend on each other maybe a lot for individual
Um,
queries.
yeah, but what would be the preferable architecture? Over here, what I showed is each of them have their own database. So is that preferable, or we have one consolidated database, but the applications are in the microservices form?
Yeah, I would say more databases then because you can sometimes a database can be locked for some write instructions, and so if you have more, you can read more frequently.
Okay, sure. Okay, so I will basically cover it. So again, the one thing I think so I missed, or I said I don't remember exactly. So the issue of monolithic applications was that there was a single point of failure. If an error occurs in the inventory function, inventory code, obviously there would be a function in the inventory class, let's say, and an error occurs and a panic error occurs, let's say, the whole application goes down. So there was a single point of failure. So if we see that over here, if we have a single database and all the microservices are using that single database, so what can happen is that again database can become a single point of failure. If that database goes down, so what's the need of the microservices? If that single database goes down, all the microservices will stop responding, because obviously it all of them have a dependency on it. And then again, If the load occurs on the products and inventory, again we see the same example of any sale date. There is a sale today, and again the load occurs on the products and the inventory microservice, and if they are using the same database, so obviously they would be querying that database again and again. So that database will again become slow, or it will become choked. So again, the point of microservices is that they should be independent. They should not cause issues, or they should not become a source of slowness or anything of that sort for other microservices. They should be independent. Again, I think so. Again, one thing can again be, if the products are changing continuously. If this is a single monolithic service, the products code is changing continuously, but accounts code is the accounts team working on the accounts code, let's say they lack something and they are working slowly. So the release part that we saw earlier, that becomes slow because of that, because products are changing continuously but accounts are not. But the application will be shipped as a whole. If it's a monolithic service, it will be shipped as a whole to the staging environment, to the production environment. You cannot ship products only, and you can basically use the old code of account, because they are mixed over there. But in microservices, what you can do is you have your own CI/CD. As I said, that over here, they will have their independent CI/CD pipelines. If whatever change is occurring in the account service will get deployed onto over there, and if there is a change in the API calls, that need to be obviously communicated to the team, the whole teams, the other teams as well. So that's a benefit of using microservices and using separate database. Okay, do we need to set up anything before project starting, or we can do that at the end, even for monolithic? There's another question for it. I am not sure about what you mean by that, Daniel. I will ask you to unmute if you can clear your question, Daniel Ahmed. So, yeah.
Yeah, Ali, I was asking about if I have a monolithic app and I want to shape it into the microservices. Do I have to recode all the application from the start?
Yeah, you would have to recode, or even you can use the code that has already been written, but create a new project for it, create a new repository for it, create a new pipeline for it, and all of those things. But you can reuse the code. But so these are sort of issues, the issues of microservices. Okay, so one of the thing is that, okay, microservices solve some issues, but they create some issues as well, so which need a lot of care to basically adapt to the microservices based architecture. The first thing is that these tools that we just basically went through. So when you are deploying a microservices based application, these tools should be there: monitoring, logging, tracing, alerting, because now the call has become distributed. Previously there was a single application logging everything, so you can easily search the logs. Now there are 10 microservices logging everything separately. So if you don't have correct logging with you, you cannot come to the bottom of the issue, that why this issue occurred. If you don't have uh, concrete monitoring setup, you cannot know which microservice is down and how should I basically work on it. So uh, microservice, another issue is the architecture part, the requirements gathering part, the design part. That should be done quite thoughtfully, because obviously, as I said over here, if you see, let me go. Yeah, the orders is calling the products microservice. So if the products microservices API interface changes, the payload, the response thing, it changes frequently. The orders microservices also needs to be updated correspondingly. So these are some issues of microservices that you have to decide these things even before writing them. You have to create a good architecture based off that. So for that, if you as you said that if you have a monolithic, you can convert it into a microservice based architecture by copying the code, but these things should be kept into mind. So that code obviously will be rewritten, because now you are making an API call rather than a function call. So previously you were just making a function call of another class, but now what you are doing is you are making an actual API call that goes over the intranet, for example. uh, so these are some things. This for central monitoring and logging, and these are the tools for them. Are there any other questions? No. Yeah, Ali Arsalan raised
Yeah,
hand.
can you show the diagram again with the distributed architecture? Yeah.
Oh,
No.
this one.
Yeah, this one. As you said, let's say order communicates with products, and if one of these signature changes, let's say products API to orders is changing, right? So,
Mm-hmm.
but the orders is still the same. So,
Yeah,
it, for me, if products team is making some changes, they will never be able to merge because of those Git checks.
because of those.
Maybe if I have some Git checks before merging my changes, let's say
Mm-hmm.
orders is they do check it with orders and everything. So how will I? Let's say I have to make changes in two of these APIs. How do I handle that?
Okay, so for that part again, another thing that comes to my mind, as you said. So, for example, if product service changed, now coming back to the CI/CD part, product service changed. The products pipeline, the CI part passed because the CI ran the unit test. The unit tests just checked the product service. It passed, the all the unit tests passed. So it went to the continuous delivery step. It got deployed onto the staging environment. Now a QA tester, or if you have the automated end-to-end test, they will run. So now when they will run, they will also test this part. So this will fail. So now your application will not go to the production environment because your application will fail over here. So now as a team, or as a basically company, or as a whatever architecture you are following in your company, you can have different teams per microservices, or you can have different sort of applications, a single team having two microservices, for example, one team having two and one team having two. So that totally depends on the size and the product of the company. So in that case, what you will do is you will obviously have a Swagger is an another application that helps creating the uh, basically API endpoints documentation that helps in that. So you will update the Swagger endpoint and share that with the orders team. So orders team will then make that corresponding changes in their application as well. So even though the products team changed and forgot to tell the order service, but it was taught in the continuous delivery and continuous deployment step. The change never got pushed to production if you have enough concrete tests written.
So you just suggesting maybe they are handling some kind of integration testing, right?
Yeah, end-to-end tests. The
Okay.
end-to-end tests or the integration tests always run on the front end or the UI. So for example, you are using Cypress or Selenium, so they will basically be following a complete user scenario, a user creating an account, user creating an order, user adding products in the basket, user using an offer. So the end-to-end tests are always based on the UI, and the UI will obviously be covering all of the microservices, the backends. So this is the front end, and these are the backends for your application.
So for this period of time where the product's API does not match the orders one, we are not in a deployable state, right?
We are not obviously our staging environment is down. Staging environment is not working, but the production didn't get affected because the latest version of the product service didn't get deployed to the production server.
Okay.
Okay, so anyone else also raised a hand? Okay, so let's move forward. Okay, so the other thing and the most important part of the complete DevOps process is the communication and the feedback. DevOps was introduced because of conflicts and because of segregated responsibilities. The developers were responsible for the dev environment, and the operations were responsible for the production environment previously. But DevOps was introduced to bridge that gap. They were introduced to basically have a single person who knows the development parts as well, who knows the operations part as well, and he can help in the complete process over there. So if there is an issue, there is anything, you should be able to communicate with the team. And one other thing related to microservices that helps over here as well. Previously what happened was, previously, for example, you have a company that has 30 employees and working on a product. So what happened was, there was 20 developers, for example, just stating an example, 5 QA testers and 5 operation guys. So the developers naturally had their own affiliation with each other. The developers naturally had their own, I would say, politics also, because politics is a part of the workplace environment. You cannot ignore that fact. The developers, they have their own group mindset. The QA guys, they have their own mindset. They have their own group going on. The operations guys, the 5 operations guys, they're working in a team. They have their own sort of the priorities and other things. But when you have a microservice based architecture, what you can do is, you can divide that groups. You can have 4 developers, 1 QA, and 1 DevOps guy or operations guy, and you can have a team, 5 team of 6 people. So over here again, going back to that architecture, the microservices based architecture. So this one team of be of account service, one team will be of orders, one team will be this. So now you, as a product manager or as a project manager, can easily see which microservice is being deployed continuously, they are working on their features, and which one is not working. So now the competition or that politics mindset has been changed to a positive mindset, because now these 6 will obviously be working in one with one mindset. They will be working for the betterment of the account service microservice. The 6 people will be working for the betterment of orders microservice, and this team will be working for its betterment. So as a result, you as a product owner get a good product with good quality features frequently. So that is one thing. And as a DevOps guy, you need to enable that communication and feedback part between the team. So if in an issue occurs, you tell the developers, for example, this there is a bug in your code. So and developers can then work on that. So you are basically covering the back of your developer. You're covering your developer. If there is a bug in their code, you can tell that tell that to the developer, or the pipeline will fail and the developer will get to know, rather than going to the production server. So previously what happened was, there were nightly builds. uh, the developers worked completely on the day, and then the pipeline ran at the night time, and then it gave a nightly build. So and then an issue occurred, and then an error occurred, for example. So what happened was, that developer was single pointed out that this build was failed because of you, in front of the whole developers or whole company, that this nightly build failed because of you. Now all the developers will have to work again the next day as well on the same thing. So that was creating issues over there. So you bring together all the workflows and the responsibilities and maintain the visibility across organizations for various events such as server development bugs and these things. So for example, whatever medium you use, Slack, Teams, or emails, or anything of that sort, so you can have a central place over there, and you can ask the guys to comment over there if there has to be an issue because of them, or if they are expecting an issue. For example, you are testing a new feature, so obviously the dev environment will go down, or dev environment will face issues. So the developer can easily communicate that to the channel, and everyone can know, okay, so dev environment is going to be unstable for 1 to 2 hours, let's say. and give the continuous feedback to the respective stakeholder. Again, the stakeholder can be the customer of the product, the product owner, or the developer, if basically the developer is also the stakeholder in that application. So if the feature is correct and deployed, take feedback from the consumer, and if there is an issue in the code, you give feedback to the developer. And if issue in infrastructure, communicate to teams as soon as possible. The DevOps guys, they do these three parts, but they don't do this part, because this means that the issue is because of them, and they tend to hide that. So if you have an automated alerting system, it will automatically create an alert for it. So, and this is an acceptable thing in a good company or with a good mindset, that these issues will occur. The infrastructure issue, the software issue will occur, but what major thing is that how you recover from it. So if you have a good alerting system, you will get an alert at once, then you can start working on fixing it. And as soon as you fix it, that alert will be gone over from there, that okay, this thing has been uh, fixed, or this thing has been processed now. So the tools for them is them for the communication are Slack, Teams, Jira, Alert Manager, and different such tools. And some there are some requirements for DevOps. So some companies claim they do DevOps just without the Agile stand up, CI code, or any other hipster stuff. So again, I will say that the DevOps is a buzzword. uh, Many companies are hiring the for DevOps engineers, but you should always look for the job description for it, because many companies are hiring system administrators, but their designations are DevOps engineers. So if your company asks you to create an AWS instance on a cloud manually, then you are not a DevOps engineer, or that company is not following DevOps engineer, because infrastructure as code is part of DevOps. That is a major part of DevOps. So if you are creating things manually, so you are not doing DevOps. If you are not doing continuous integration, you do not have any pipelines, so you are not using DevOps or anything of that sort. So uh, make sure of that. Previously what happened was, in I would say 2 to 3 years ago, people were hiring data scientists, but they were doing data entry part. So that is the same thing over here. Companies are hiring for DevOps because it is a buzzword, but actually they are doing system operations thing, or system ID administrator things. So you should work on that as well. So the summary out of all of this is that the DevOps, it is a combination of the cultural philosophies, the practices, and the tools. This philosophy should be in the mindset of the company, or the team, that things should be automated. Obviously, automation will take some time. For example, if I want to deploy my application today, that is not possible, because automation takes time. But that automation will help me in the future. It will help me a lot in the future, when we say you have to deploy thousands of applications or basically deploy hundreds of features in a single day. So that automation will work now at that time. But today obviously you have to invest time to create that automation. So the leads, or the I would say managers, are not focused on that. They say that deploy things manually, but I need it today, I don't want automation. So that thing should be discouraged, because that's against the philosophy of a DevOps team. Increase the organization's ability to deliver applications at high velocity. So if you have all the principles incorporated in your setup, obviously the delivery of your applications will be at high velocity. The dev and the ops teams are again, they are no longer siloed, sometimes even merged into a single team. So what DevOps has done is, some developers have moved into the DevOps field, and some operations guys that didn't know development, they learned how to write code, and they learned basic development, and they moved to DevOps field. So it became sort of a one team, the DevOps thing. The quality assurance and security teams may also become more tightly integrated. Again, as I said, that you can break the teams according to the microservices base. So four developers, one DevOps, and one QA. and teams use practices and tools to automate processes. Again, the automation is a major part of DevOps. You automate things rather than you do things manually, and then you hope uh, things will work right. But that should not be the path. That should not be incorporated in the culture of the company. Again, this is the summary of DevOps, the same photo that we started from, that a DevOps engineer is responsible for all of these things. So when we said that DevOps is the highest paid job, so one of the reasons is that the DevOps has to learn a lot of tools. The tools are changing day by day. So for example, as I moved from the philosophies over here, so the DevOps needs to know how to integrate Slack with pipelines, how to integrate Alert Manager. A DevOps should know any of two to three of these tools for the monitoring, logging, and tracing and alerting. So DevOps should know these tools. Now coming back to the infrastructure as code, so these DevOps should know any two of these uh, tools. So the number of tools, as you can see, are quite a lot. AWS, Azure, and all of these provide their own managed services as well. So for example, if we see over here the CI/CD, so GitHub Actions, GitLab CI, Jenkins, these are all other tools. And then Azure DevOps is another CI/CD tool, IBM DevOps, AWS Code Pipeline. So these are all other tools as well. So the number of tools are quite high. But again, the point is that you should be expert in one to two of these tools and know the concepts, that how things work and how should I basically enable DevOps in my company. Just other things are just scripting or writing basically pipelines that can be done by learning or by googling. But if you don't know what you have to do as a whole in your company, then obviously that's an issue. So as a DevOps engineer, you have might be able to ask to code as well. You should be able to write pipelines to build the application, to test it, release, deploy, and then monitor and log and alerting, all of those parts over here. Summary, again, the CI/CD, what it means is what you can have in your teams as a basically single principle. Obviously, this is not a I would say a hard coded principle that you have to release once a week. It depends on the feature that you are releasing, but you can have a soft target for your teams that you have to release once a week. And the quality of code, obviously, that can be managed by different tools that provide you with all the quality analysis of your code. The other major thing that happened in the DevOps realm is the microservices. You should basically write microservices or basically work on the architecture of the microservices, so that you get to know that how applications are communicating with each other. So they are just loosely coupled components deployed in automated way. Responsibility, again, the responsibilities are now shared, that as the people are divided into different teams, so now each of them has a responsibility on his own product. And you as a product manager, or you or a project manager, can ask the team lead of that team that why things are being delayed, or why there have been such issues. So you can easily get to the bottom of the issues if there are any in a DevOps enabled company. In the infrastructure, cloud, containers, Kubernetes, build once, run anywhere. So cloud, again, is one of the major thing in infrastructure, that you should not be working on premises if there is not a security thing, or not a data security thing. So you should be moved to cloud, or even if there's a data security thing, you can enable OpenStack or have a local cloud for yourself. But you should do that rather than setting up the applications on physical servers. You should be running them as part of the cloud framework. Then you should be moved to containers if you have microservices. Again, as I said, the containers are the de facto way of deploying microservices and working on them. And a DevOps engineer summary, my tips for a DevOps engineer would always be tool independent. all of the previous tools that I have mentioned, there are a lot of tools, and the tools are increasing day by day. That I can assure you. I have been working for around 5 years, and even today I can't say that I have worked with 50% of the tools as well. I have worked with almost, I will say, 50% of the tools, but not more than that, because the number of tools are quite high, and each new tool is being released, I would say, weekly or monthly. New tools and new features are being released. So be tool independent, but obviously you should know one to two major players of that domain. So in CI/CD, Jenkins, GitHub Actions are some main players. In monitoring, Prometheus, Grafana are. In Kubernetes, EKS is, or AKS, they are one of the major things. Then be adaptable. Now, those are not the days that you are a Java developer for 15 years or a .NET developer for 20 years. Now you cannot be that. You have to be adaptable. Things are changing. Even in the development field, things are changing. React came, Node.js, React.js, Angular, a lot of new frameworks are being built. So if you are stuck being a Java developer for 15 years, that will not help you in any way. You have to be adaptable. You have to change your YAM. You have to learn new technologies. If you do not, you will remain back, and the industry will move forward. Development experience. If you don't have any development knowledge, if you don't have any development knowledge, I will recommend you start with basic shell scripting. Start with how to write basic shell scripts, because scripting is a major part of DevOps. If you don't know how to write a script, you will suffer a lot. So you should have a basic development experience. You should know how to write to bash scripts, how to automate those things. And then one of the most important things that I basically preach is able to learn and unlearn. So most people preach this able to learn, but I myself have added this part as well, and unlearn. What happened is, and it has happened with me as well, I preach something new to my, let's say, seniors or anyone. What they say is, no, we don't want to change anything. But the question is, why do they want to change? If there is a better thing in the market which is better than the tool that we are using, why shouldn't we move to that tool rather than sticking with the old tool? So you should be able to learn new things and unlearn new things, unlearn previous things that are not the market standards now. So these are some of the basic uh, summary, or my advices for a DevOps engineer would be these things. And the major would be you should be able to learn new things, and you should be acceptable to learning new things and unlearning the previous things that you believe or that are not the industry standards now. And one thing that I would like to add over here is have a community. Build a community, build a network of yourself, because as I said, DevOps engineers demand are high but supply is less. So be connected with the relative persons, how they are working and how they are doing things, and which new tool is coming. So just a brief recap of all of this in our course that we cover in Dice Analytics. The one is already running. We have covered 4 weeks of it. All of these things are covered. GitHub, all of that is covered. Containers, Docker containers, Docker Compose, Docker Swarm, Kubernetes, Jenkins, GitHub Actions, uh, Helm, uh, GitHub Actions, Terraform, Ansible. So all of these things are covered in that course. Just basically recap of all of these tools that I have mentioned, and you can even Google that yourself. That these are the industry standard tools that we are using or we are recommending in the course. Now, if you have any questions, you can ask over there, and I will just be showing a simple demo of how the GitHub Actions work and how the CI/CD part works. So this is a sample Golang application that I have created for the demo purposes, and you can see over here the CI is also passing and the CD is also passing over here. So if I go to my other branch, the add die seminar, this is the new branch that I have created, and I have created a pull request for it as well already. So this is a pull request that I have already created. So why isn't it showing? Okay, let me see the actions at I seminar. Okay. So what I have done is I will just give you a brief overview of what the application does is it has an API endpoints. It has multiple API endpoints. A basics one, this is a slash which gives a no endpoint, a slash hello which gives hello you have requested hello, slash health it sends up, and slash dice it tells us that the dice class has started and 12 September is the fifth week. So this was the one that I added for my class, which was in on 12 September of the previous year. And the last one is the slash count part. So if I show you, this is deployed on the dev environment, counter dash dev. This is a public uh, Kubernetes cloud that I am using, Sivo cloud. So that's why it's insecure. So if you have any issues with that, because it is an insecure URL, but that is because this cloud is not, or this domain is not in my control. So if I show you over here, so this is a count endpoint which shows one. If I refresh it, 2, 3, 4, 5, so the count will keep increasing. So what we are doing is in this pull request, we are adding a new endpoint of dice seminar, and we are adding is dice seminar is in progress on January 29, 2021. So this is the endpoint that I have added, which has been added as the pipeline ran this seminar, and you can see that over here. But what I will be doing is I will edit this, and I will, let's say, add anything. So this is an example of if you want to add a feature. So over here I will say is in progress on itne at, let's say, 7:45 p.m. Pakistan. Okay, but not this. I will say the audience is, sorry, is quite good. So I will just add this part over here. So this should be deployed onto my dev environment when I am creating the pull request for it. So this is my pull request method. So I created the pull request. I have written a pipeline for it that will be triggered. So as soon as my code went, a GitHub action would have been triggered. So if I go over here, my update main.code that I just did now, so a pipeline has started running. If I go over here and we see the details of it, so what, there are different steps that I have set up. What it will do is it will set up go binary, check out the code, basically this code that I have written. It will build the code, it will initialize pipeline, generate variables that what image name or what it should be, set up Docker, log into Docker Hub, build and push the Docker image, comment on PR, and if there is a failure, it will notify that, and then deploy onto the dev environment. It will deploy onto the dev environment. Over here, if we can see the production environment, so there is no endpoint for dice seminar at the moment. So there is no endpoint for dice seminar. This is a new feature that we are working on, for example. So the pipeline will run, these are the different steps that will be completed. If I show you the basic language or basic YAML, so these are my CI CD. So CI will run on pull requests over here, as I have mentioned, it will run on pull requests, and this is the code. This will build the code, this will initialize the pipeline, it will tell me on the pull request, it will generate variables. This is our, I'm generating the variables for my image name, image tag, and all of those things. Then I am Docker logging. This all are based on secrets, so you cannot see the values of this. So even though this is a public repository, this is an open source repository, you can see the code and all of that, but you cannot see the secrets that I have mentioned. So I will build and push the Docker image. I have mentioned the Docker file for it. It will comment on the PR if it's successful, that the image is available for testing, whatever image it is. It will create, it will mention that if it's a failure, it will notify me that the pipeline failed, and then it will deploy onto the dev environment my image. So as soon as that happens, the pipeline is still running. Meanwhile, if any one of you has any question, he can ask in the Q&A. Okay, so there was a question previously. There are many tools in DevOps like Jenkins, Docker, Ansible, Chef. Can you please tell how should a beginner start with? Okay, so the question again being, how should a beginner start with? As I said, if you don't have a development background, you should learn development, basic shell scripting, basic that part first of all. Then you should move on to Git and GitHub. That is because Git and GitHub or will always be used in any good company that you go to. In any good company, and by good I mean 5% good, they will be using a version control system. That might be Git, and that should be Git, because Git is the most popular version control system too. There are others, TFS and SVN, but they are quite unpopular nowadays. So most of them will be using Git, so you should have some familiarity with Git. Then I will say CI/CD, GitHub Actions and Jenkins are the major part of it. And then one of the biggest tool, Docker containers, that you should have. So this is the path: Git, bash scripting, first of all, bash scripting, Linux, a bit of those things, Git, CI/CD, Docker containers, contain how containers work, what is the difference between a container and other modes of deployments, and then Kubernetes. So this is the complete cycle there, and then the infrastructure as code, Terraform and Ansible. So you should work on this basically path. And you can see that this has pushed the image, build and push Docker image. It has pushed onto Docker Hub. I will just show you on my Docker Hub as well. And this is, I have deployed it. So this was the DICE seminar, the previous URL. Now if I refresh the page, so you can see the change has been added onto my dev environment. So if I have a QA tester at the moment, so he will test this, whatever feature that I have added. And then what will happen is that the pull request will get merged onto the master branch. So this was the pull request. It passed successfully. I got a notification over here as well. If there was an error, I would have gotten that as well, that their pipeline has failed or not. So I've gotten this. I can test it locally as well, or I have deployed it onto my dev environment and tested that. So now what I will do is I will merge this pull request. So you can use, basically I'm an administrator, so I can merge it, but you can have approvals. For example, if someone from your team approves it, only then you can merge the branch to the master branch. So now my master branch has been merged, and now you can see a new pipeline has started running, which is the CD part. So now the CD part will start running, and it will update the production server and will create a Git tag for me. So what you can do is you can have Git tags for it. So for example, if I ask you that what is the code related to version 1.2.10, so you can easily check that from Git, that what code was there in version this. So we are using Git tag for versioning. So previous version is 1.2.11, the new version will be 1.2.12, and that will be deployed onto the production. So at this moment you can see that there is no endpoint for this DICE seminar. So as soon as the pipeline completes, this pipeline is running, it will take almost 3 minutes. So after 3 minutes it will deploy onto the production, and we will have a CD setup in place. Pipeline is still running. Any other questions? Can you give us a Coursera or Udemy to learn about DevOps? Okay, so basically again the point being is, if you go to any public online community to learn things, they are helpful. But again, as I said, that DevOps is not a field where you can learn things by just reading the documentations and all of those things. If you don't have on basically hands-on experience, so if you haven't written a Docker file but just have read what a Docker file is, so that will never help. Similarly, if you just read how a car can be repaired and you haven't ever worked or basically worked on repairing a car, you can never ever do that thing. So again, DevOps is a hands-on thing. So if you don't have a hands-on, just going through Coursera courses or going through an online videos will not help you, that I can guarantee, because I have seen people who might have read this and I have taken interviews from them. So they can tell the bit of theory, but when I ask them to write a basic Docker file, they are unable to do that. So they are totally unable to do that thing, and I can easily get to know that who has done the hands-on things and who hasn't done, and who hasn't just read the theory for it. So, and even I will tell you that in most of the hiring that I have seen, not only mine but most of the hiring that I have seen, they always give you a hands-on task to complete. They almost every time they give you a hands-on task to complete in the hiring process. So if you complete that, then you are basically go on to the next phase or of those things. Okay, so now our master pipeline is also run, the CD part is also run, and if I go to the production environment endpoint, so you can see that I am able to see that endpoint onto my production endpoint. So that's how things can be basically achieved in a CI/CD environment in a quite simple way. I have written a simple pipeline. I didn't had any tests over here, but if I had, I would just have written git go test, basically go test minus v. Over here I'm building the code only, but if I had any unit test, I would have written go test this. And now I have a URL, so I can have a public or end-to-end test to go through this URL, or basically API call this. Okay, when new course will start for beginner as they only have system administrator background? Okay, so for that, what we do is we basically start with basic scripting. We introduce you to Ubuntu, because for a DevOps engineer, Linux and Ubuntu scripts are important. Some companies are focused on Microsoft, so obviously they focus on the PowerShell and those things, but majority, I would say 80 to 85% companies are focused on Ubuntu and Linux. So the next course, as I said, that the current course is already running. 4 weeks have passed and 4 weeks still have to go, and then I think so after a month or two the next iteration will start. That will be shared on the Dice Analytics page. You can follow that for future updates, and as you have shown interest in this seminar, you will be getting updates as well. So I will urge you to like or basically follow the page of Dice Analytics for that. And as I said, that we can create a network of yourself as well, so you can connect with me and as well, and connect with Dice Analytics page as well for future references. Okay, any other questions? If we are almost over 8 minutes left, if you have any questions, please you can raise the hand. Yeah, yeah, Ali Islan, any question?
Yeah, so when is your next course starting and what are normal timings? Like people would be joining from around the world and not just Pakistan.
Okay, so as I said, the next course most probably still I would say 2 months, after 2 months, because 1 month for the current course that is already running, and then almost 1 to 1.5 months after that the next course might start. And the timings are on weekends. we basically run on weekends. As I And other thing is that I and the other person that we basically go through the course, we both have existing jobs and we both are working in the DevOps field. So another benefit is that we know what the trends are at the moment. So the timing is Saturdays, 10 to 6 every Saturday, with a break in between for 1 hour. So that is the usual timing for the course.
And can you also confirm here what are the charges, or it has to be between?
The charges would be shared on the page. You can ask the Dice Analytics
Okay.
admin for that.
Yeah.
Okay, Tanzil, you have raised your hand. Any question? Ali Arslan again raised the hand.
Sorry, just also
No,
sent by chat. Will you be also covering Git actions in this course?
sorry.
Will you be covering Git actions as you showed here?
I basically start on it. I give the basics for it, for GitHub Actions. If anyone wants to learn it, he can do that after that. But I obviously give the initial push on it, and I go through the different parts of GitHub Actions. But obviously, we focus more on Jenkins because that is the industry leader at the moment. But in the near future, or I would say in the far future, that might be changed. But for if because of that, I teach GitHub Actions, or I basically have incorporated GitHub Actions into the course. Previously, it was not part, but as GitHub Actions is gaining popularity, so I have included that in the course. But obviously a full-fledged start to end GitHub Actions would be quite difficult because we already have 8 tools in the 8 weeks course. So if you want to basically know more about GitHub Actions, I will enable you till that, but after that you would have to do that on yourself. Oh,
In the workshops, do you like? Do we have to do some work on our own, or everything is covered in those 8 hours? Like also on hands.
yeah, it is covered. Obviously there are assignments after that, or if anyone's labs are missed or left, so they have to complete that. But there are assignments, there is a complete project for it that covers the major industrial aspects, that how CI/CD or how a complete software development lifecycle works. So we have a project based on that. There are assignments as well, but majority of that is covered in the class. But obviously some of it, if it's left, because everyone's pace is different in a class, so if someone's labs are left, they have to complete that by the home.
And is everything online?
Yeah,
Okay,
currently
perfect.
the last two iterations are totally online. So we basically have a complete setup for that, for the online iteration, and you get the recorded links as well, which are there with you forever, so you can go back to that course anytime. And we have a dedicated Slack channel for it as well. We create one, so you can go through that in future as well. If you face any questions, you can ask there. Okay, can you please send the recorded demo link? I think so it's already live on Facebook, so you can see from there, or you can ask the Dice admins for that. They will be more than happy to help you. So then again, I think so there aren't any more questions. If there are, please raise your hand. We are just 3 minutes away from the closing time. And again, I would like to thank all of you for attending this session. If there are anything, okay, someone raised the hand. Tanzil raised the hand. Or,
Yes, Ali, I have a question. If
yeah.
we started from before the 2 months, so is there any possibility to run this batch? Because maybe the last time I visited the institute, but unfortunately, there was one person just gave me, there's a due to COVID, we have the finished the classes and set up the online, but unfortunately I could not get the this session. So I have to join as immediate if there is any
Uh,
possibility within a
uh,
month or something like this.
that wouldn't be possible because, as I said, the current iterations are already running. 4 weeks are left for that, so a month almost, and then we have almost a month's break for it. So, but obviously, that depends on DICE administration's decision that how quickly they run. But obviously, it cannot be run before a month because we already have a course running.
Okay, sure. Thanks.
Is there any chances to hold classes physically? Not at the moment because of the COVID situation. But obviously, as soon as the COVID restrictions are lifted, we will be having the physical sessions at DICE Analytics. But for the foreseeable future or for the near future, I can't say much about it because the situation is quite, I would say, difficult or cannot be planned or unplanned. Basically, cannot say anything about that. That when the physical classes will start. But that I can guarantee that our online setup is quite good already. We have tablets through which we handle all the whiteboard stuff, all the writings, and all of those things. And we have a dedicated Slack channel. We have a dedicated Zoom account where you can get all the recordings for it. So the setup is already quite good for online. And one of the benefits of online is that there can be people from different countries as well. So okay, so the time is up. Again, I would like to thank all of you for attending this session. If there are any suggestions you want to give, please do that. You can message me on LinkedIn or anything. Or if it went good, you can also praise that. I would be more than happy to accept it because the feedback is one thing that helps me incorporate things in the next sessions. So thank you, all of you.
All right, so that's all about the webinar. Thank you so much, Mr. Ali. We had a great time on this webinar with you. And to all the attendees, we have mentioned an email in the chat section. You guys can email us for the recording or any queries regarding our trainings at info@diceanalytics.pk. Thank you so much, everyone.
Thank you. Bye, everyone.
Thank you. Bye bye.
Thank you. Thank you. Thank you, Andy.